Okay, so today's class will discuss the theory and procedure of this experiment. So I've told you that in the first experiment we will take three objects. One is cube, and hollow cylinder, and the first one is sphere. So today we will discuss about to calculate the volume of sphere by using Vernier Caliper. So in your physics practical copy, in the first blank space, you have to draw the diagram of this Vernier Caliper. You have to draw this diagram, and in the next page, you have to write down first. You have to write down the aim of the experiment, which is to determine the volume of a sphere by using Vernier caliper. In the next page, you have to uh, first you have to write down the aim of the experiment, then you have to write down the apparatus required, which is Vernier caliper and spherical body. So these are the apparatus required to do this experiment. First you have to write down the aim, then you have to write down the apparatus required, then you have to write down the theory part. So, in the last class, I have already told you all about Vernier scales and why this scale is used. But today, I'll just quickly explain the theory. So, a vernier caliper has two scales, one main scale and a vernier scale, which lies along the main scale. So, there are two scales in a vernier caliper. This one is the main scale, and this small part is the vernier scale. This is the vernier scale. This small part is vernier scale. So, the main scale and vernier scale are divided into small divisions through different magnitudes. Thus, main scale is graduated in centimeter and millimeter. So, the minimum division of the main scale is in centimeter, and one division of the vernier scale is slightly smaller than 1 millimeter. So, we can count we can count the main scale reading in centimeters also. Here the vernier main scale of the vernier caliper is up to 15 centimeter. We can count the main scale reading in centimeter and in millimeter also, but one reading of the vernier caliper is smaller than 1 millimeter. The main scale has it has two fixed jaws, A and C. So these two jaws of the vernier caliper is fixed in the main scale, projected at right angle to the scale. The sliding vernier scales has the jaws B and G projected at right angles to it, and okay, the sliding vernier scale has jaws B and D projecting at right angles to it, and also the main scale and the metallic strip. So these two jaws can be moved. These two jaws are movable jaw. We can move these jaws B and D by using the screws, and this metal strip is used to measure the length and depth of any object. We can move these jaws also forward and backward. Move this metal strip or increase its length, decrease its length by using the screws. These two by using these two screws, we can increase the length of the metal strip, or we can decrease its length. And these two jaws are movable jaws. We can make this forward or backward by using the screws. The zero of the main scale and the vernier scale coincide when the jaws are made to touch each other. So when we made the A jaw touch B jaw, then the zero of the vernier scale touches the zero of the zero of the main scale touches the zero of the vernier scale. When we make these two jaws, A and B jaws touch each other, or we can say when we close the vernier caliper, the zero of the vernier caliper touches the zero of the main scale, touches the zero of the vernier scale. The jaws and metallic step are designed to measure the distance diameter of objects. Okay, so actually these two jaws are used to measure the internal external diameter or length, breadth, etc. And these two jaws are used to measure internal diameter only, and this metal strip is used to measure the length or depth of any object. The knob P is used to slide the vernier scale on the main scale. Screw S is used to fix the vernier scale at a desired position. So by this knob we can move the B and D jaws, and by using the screw S we can tighten the object in between these two jaws. When we have to fix our required objects in between these two jaws or these two jaws, we will first move this jaw using this screw, and then we will tighten the object in between the jaws by using the screw S. Okay, 1 second. Huh? মই মিউট হৈ আছিলো নেকি? Okay, students, শুনা পাইছিলা নে কিবা? নে মই মিউট হৈ আছিলো? মই আনমিউট কৰিবই পাহৰি গৈছিলো, ৰবা আকৌ কৈ দিব লাগিল এতিয়া। ঠিক আছে, এইখিনিলৈকে বুজাইছিলো ন? এইখিনিলৈকে শুনিছিলা? এইখিনিলৈকে শুনিছিলা?
তাৰ পাছৰখিনি পৰা
ইয়াৰ পিছত
শুনিছিলো মেম।
ঠিক আছে, ৰবা ইয়াৰ পিছৰখিনি পৰা কৈ আছো। আচ্ছা, ঠিক আছে। তো লিষ্ট কাউণ্টটো আমি অলৰেডি জানো লিষ্ট কাউণ্ট কি হয়। ইট ইজ দ্য স্মলেষ্ট ডিভিজন আপ টু হুইচ ভাৰ্নিয়াৰ কেলিপাৰ কেন মেজাৰ, ৰাইট? এইটো হ'ল লিষ্ট কাউণ্ট, যিটো আমি অলৰেডি we have already discussed about the least count, that least count is the smallest divisions up to which vernier scale can measure, or it is the length gap between the smallest division of main scale and one division of vernier scale. So the smallest division is in millimeter, right? 1 millimeter. The smallest division in the vernier scale is 1 millimeter. So 1 millimeter minus 1 vernier scale division will be the least count of the instrument, or least count of the vernier caliber. The difference in magnitude of one main scale and one vernier scale division is called the least count of the instrument, or it can be the smallest division that the vernier scale can measure is the least count. So by using this formula we will be calculating the least count. So the formula is the magnitude of the smallest division on the main scale divided by total number of small divisions on the vernier scale. The magnitude of the smallest division on the main scale is 1 millimeter. The total number of small divisions on the vernier scale is 10. So the vernier calibers you will be given in our university usually has 10 divisions. So 1 divided by 10 equal to 0.1 millimeter. The measure it will be in millimeters. If we convert it into centimeter, that will be 0.01 centimeter. Usually we write 0.01 centimeter. So since the main point of this experiment is to calculate the volume, so this will be the formula for calculating volume of the spherical object, which is V stands for volume, equal to 4 by 3 R cube. This is the main formula. So up to this part you will be write it down in your practical copy. Up to this part, this is the theory part. Up to this, after this, the procedure will I'll explain the procedure. You don't need to write down the procedure. You just write down up to this. So first you will be in the first blank space of your copy. You will be drawing this diagram. Then you will be then you will write down the aim of the experiment, then apparatus, then theory up to the formula, up to the formula of volume. So any questions? কাবাৰ কিবা কুৱেশ্যন আছে নেকি থিয়ৰিটোৰ ওপৰত? নাথাকিলেও নো বুলি কৈ দিয়া। মেম আছামিছত এবাৰ বুজাই দিব। আচ্ছা ঠিক আছে। So Prince Kumar Boru has raised a hand. What is your question? Okay. So first তোমালোকৰ প্ৰেক্টিকেল কপিখনত যিটো ব্লেংক স্পেচ থাকিব, আচ নতনা পেজ যিটো থাকিব ন, সেইটো তোমালোকে এইটো ডায়াগ্ৰামটো ড্ৰ কৰিবা, ভাৰ্নিয়াৰ স্কেলৰ ডায়াগ্ৰামটো, ঠিক আছে? দেন তাৰ নেক্সট পেজটোত ফাৰ্ষ্ট এইমটো লিখিবা, টু ডিটাৰমাইন দ্য ভলিউম অফ এ স্পিয়াৰ বাই ইউজিং ভাৰ্নিয়াৰ কেলিবাৰ। এইমটো লিখাৰ পিছত তোমালোকে এপাৰাটাছ ৰিকুৱাৰ্ডটো লিখিব লাগিব, সেইটো হ'ল ভাৰ্নিয়াৰ কেলিবাৰ্ছ এণ্ড স্পেৰিকেল বডি। Then you have to write down the theory. থিয়ৰিটো তোমালোকে ফৰ্মুলাটোলে লিখিব লাগিব, আৰু তাৰপিছত প্ৰচিডিউৰটো লিখিব নালাগে, প্ৰচিডিউৰটো কপিত লিখিব নালাগে, তোমালোকে থিয়ৰিৰ এই ফৰ্মুলাটোলৈকে কপিত লিখিব লাগিব। চ' ফাৰ্ষ্টতে থিয়ৰিটো হ'ল যে ভাৰ্নিয়াৰ স্কেলত দুটা স্কেল, ভাৰ্নিয়াৰ কেলিবাৰ দুটা স্কেল থাকে, ওৱান মেইন স্কেল আৰু এটা ভাৰ্নিয়াৰ স্কেল থাকে। মেইন স্কেলটোত তুমি চেণ্টিমিটাৰত থাকিব আৰু মিলিমিটাৰতো থাকিব। তো চেণ্টিমিটাৰত থাকিব 15 চেণ্টিমিটাৰলৈকে। ইউজুৱেলি আমি চেণ্টিমিটাৰতে কেলকুলেট কৰোঁ মেইন স্কেল ৰিডিংটো, বা মিলিমিটাৰটো কৰিব পাৰোঁ। আৰু ভাৰ্নিয়াৰ স্কেলটোৰ এটা ডিভিজন 1 মিলিমিটাৰতকৈ সৰু হয়। চ' এইটো আৰু এইটো যি দুটা জ আছে ন, এই দুটা মেইন স্কেলৰ লগত ফিক্সড হৈ থাকিব, আৰু এই দুটা জ আমি মুভ কৰিব পাৰিম, লগতে এই ষ্ট্ৰাইপটোও আমি মুভ কৰিব পাৰিম। চ' বাই ইউজিং দিছ টু স্ক্ৰুজ আমি এই দুটা মুভ কৰিব পাৰিম। আৰু কিবা যদি বস্তু ভিতৰত অবজেক্টটো যেতিয়া আমি ফিক্স কৰি ৰাখিব লগা হয়, তেতিয়া আমি এই স্ক্ৰুটোৰ সহায়েৰে এইটো টাইট কৰি কিনে ভিতৰত ফিক্স কৰি দিম অবজেক্টটো। আৰু এইটো ব্যৱহাৰ কৰা হয় ইণ্টাৰনেল ডায়ামিটাৰ মেজাৰ কৰিবৰ কাৰণে, চেম প্ৰচেছেৰে। আৰু এইটো ব্যৱহাৰ কৰা হয় এক্সটাৰ্নেল ডায়ামিটাৰ বা এক্সটাৰ্নেল ডায়ামিটাৰ বা এনি ডায়ামিটাৰ, আৰু কি কয় লেন্থ ব্ৰেড এইবিলাক মেজাৰ কৰিবৰ কাৰণে এই দুটা ব্যৱহাৰ কৰিম। আৰু এইটোৰে আমি লেন্থ বা ডেপ্থ এইটো বস্তু মেজাৰ কৰিব পাৰিম। চ' এইটো ইনষ্ট্ৰুমেণ্টটো ড্ৰ কৰিব লাগিব, তাৰপিছত এইখিনিলৈকে লিখিব লাগিব। তাৰপিছত আহিল লিষ্ট কাউণ্ট। লিষ্ট কাউণ্টটো আমি জানো অলৰেডি। লিষ্ট কাউণ্ট হ'ল ভাৰ্নিয়াৰ স্কেলৰে স্মলেষ্ট কিমান সৰুলৈকে মেজাৰ কৰিব পাৰে, সেইটো হ'ল ভাৰ্নিয়াৰ স্কেলৰ লিষ্ট কাউণ্ট, বা সেইটো হ'ল ডিফাৰেঞ্চ বিটুইন এটা মেইন স্কেলৰ সৰু ঘৰটো আৰু এটা ভাৰ্নিয়াৰ স্কেলৰ ঘৰৰ মাজত যিটো ডিফাৰেঞ্চ হ'ব, সেইটোৱে হ'ব লিষ্ট কাউণ্ট। চ' যিহেতু ভাৰ্নিয়াৰ স্কেলৰ এটা ঘৰ 1 মিলিমিটাৰ থাকে আৰু সেইটোৰ আমি ডিফাৰেঞ্চ ওলাম, তাৰমানে কি হয়, ভাৰ্নিয়াৰ স্কেলে 1 মিলিমিটাৰতকৈও সৰু বস্তু মেজাৰ কৰিব পাৰে, কিন্তু কিমানলৈকে মেজাৰ কৰিব পাৰে সেইটো আমি লিষ্ট কাউণ্টটো কেলকুলেট কৰিব লাগিব। লিষ্ট কাউণ্টটো কেলকুলেট কৰা হ'ল এইটো ফৰ্মুলা। চ' এইটোৰ কাৰণে ফাৰ্ষ্টতে আমি ওপৰত বহাম স্মলেষ্ট ডিভিজন অফ দ্য মেইন স্কেল, সেইটো 1 মিলিমিটাৰ হ'ব। আৰু যিবিলাক তোমালোকক আমি ইউনিভাৰ্চিটিত যিকেইটা ভাৰ্নিয়াৰ কেলিপাৰ তোমালোকক দিম এক্সপেৰিমেণ্টটো কৰিবৰ কাৰণে, সেইটোত 10টা ডিভিজন থাকিব ভাৰ্নিয়াৰ স্কেলত। চ' 1/10 = 0.1 মিলিমিটাৰ। চ' যদি আমি চেণ্টিমিটাৰত কনভাৰ্ট কৰোঁ, তেতিয়াহ'লে কি হ'ব, 0.01 চেণ্টিমিটাৰ। চ' লিষ্ট কাউণ্ট হ'ল 0.01 চেণ্টিমিটাৰ। তাৰমানে আমি 0.01 চেণ্টিমিটাৰৰ সমান সৰু বস্তু ভাৰ্নিয়াৰ স্কেল ইউজ কৰি মেজাৰ কৰিব পাৰোঁ। চ' এইটো হ'ল ভাৰ্নিয়াৰ, এই যিটো আমি স্ফেৰিকেল বস্তুৰ ডায়ামিটাৰ মেজাৰ কৰিম, তাৰ এইটো ভলিউম উলিওৱা ফৰ্মুলা। ভলিউম উলিওৱা ফৰ্মুলাটো হ'ল V = 4/3 পাই r³। This is the main formula for calculating volume of the spherical object. Okay. Then the procedure part. You don't need to write down the procedure in your practical copy. So the procedure consists Keep the jaws of the vernier caliper closed. Observe the zero mark of the main scale. It must be perfectly coincide with that of the vernier scale. So first we have to see uh, the first we have to close the vernier caliper and see the zero mark of the main scale is coinciding with the zero mark of the vernier scale. Basically, first we have to see we have to close the vernier caliper and see the zero of the main scale is coinciding with the zero of the vernier scale or not. So then look for the divisions on the vernier scale that coincides. Okay, only procedure we don't need to write. Ma'am, yes, you don't need to write the procedure part. Up to the formula, you have to write up to this formula, and after that, you don't have to write. I am just explaining the procedure so that it will be helpful when you do this experiment practically. Look for the divisions on the vernier scale that coincide with a division of the main scale. Use a magnifying glass if possible and note the number of divisions on the vernier scale that coincides with the one on the main scale. Position your eye directly over the division mark so as to avoid any parallax error. Uh, so this is how we will calculate the vernier scale. I told you that in that class that I will explain you how to find out the vernier scale reading. So this is how we will find out the vernier scale reading. We have to see which line of the vernier scale is coinciding exactly collinear with any of the line on the main scale. We have to see which line of the vernier scale is coinciding or collinear with any line of the vernier scale. So if the fifth line of the Vernier caliper is collinear with any line of the main scale, then the Vernier scale reading will be 5. So we have to for calculating the Vernier scale reading, we have to see which line of the Vernier caliper is coinciding with any line of the main scale. Uh, that will be your Vernier scale reading. Gently loosen the screw to release the movable jaw. Slide it enough to hold the sphere cylindrical body without any under pressure in between the lower jaws. AB, the jaw should be perfectly perpendicular to the diameter of the body. Now gently tighten the screw as to clamp the instrument in this position of the body. So first we will using the screw we will move the movable jaws that are B jaw, that is the B jaw. We will move the jaw using the screw and then we put a spherical body in between A and B and then we will tighten or fix the sphere in between the jaws. Carefully note the position of the zero mark of the vernier scale against the main scale. Usually it will not be perfectly coincide with any small divisions of the main scale. Record the main scale division just to left the zero mark of the vernier scale. So for main scale reading, what we have to see? We have to see the zero mark of the vernier scale is collinear with which line of the main scale. If the zero of the vernier scale is coinciding with 2 of the main scale, then the main scale reading will be 2. So for main scale reading, we will see the zero of the vernier scale is coinciding with which line of the main scale. That will be main scale reading. Start looking for exact coincidence of a vernier scale division with that of a main scale division on the vernier window from left to right. Note its number, say n carefully. So this is how we calculate the vernier scale reading. I already explained to you. So we have to see which line or which point of the Vernier caliper is collinear with any line of the main scale. If the Vernier scale, say N, Vernier scale nth line is collinear with any line of the main scale, then the Vernier scale reading will be N. Multiply n by least count of the instrument and add the product to the main scale reading noted in step 4. Ensure that the product is converted into proper units, usually centimeter, for addition to be valid. So then we have to multiply the Vernier scale reading which is taken as n. So we have to multiply the Vernier scale reading with the least count. So n into 0.01. Repeat step 3 and 3 to 6 to obtain the diameter of the body in different position and its curved surface. Take 3 sets of reading in each case. So we will move the position of the sphere and we will take the diameter of the sphere in different positions for the accuracy of measurement. Record the observation in the tabular form with proper units. Apply zero corrections if need be. Okay, so we have to record this observation in the table. In this table, find the arithmetic mean of the corrected readings of the diameter of the body. Express the results in suitable units of the with appropriate number of significant figures. So since we calculated the diameter in so many times, so to find out the proper value we have to take the mean of the diameters. Say if we take the diameters 4 times, then we have to sum all the 4 values, then we have to multiply it by 4 to find out the mean of the diameters. So this is your table. First, we have to write down the main. First, we have to write down the main scale reading. Main scale reading is the to find out the main scale reading. We have to see the Vernier scale 0 point is coinciding with which point of the main scale. That will be main scale reading. Then we have to see the Vernier scale reading number of coinciding Vernier divisions. That which line of the Vernier caliper is collinear with any line of the main scale, that is Vernier scale reading. Then we have to take the Vernier scale, multiply the Vernier scale reading with least count. Then we have to sum this value and this value. We have to sum this value and this value. That will be your diameter. We have to sum the main scale reading with the Vernier scale reading. Vernier scale reading is this one, which we multiplied with 0.01 centimeter. So by adding these two values, we will get our desired diameter. See here, we will calculate the diameters up to 4 times. Then we have to calculate its mean. Okay, then after calculating the diameter, we have to find out the volume. So to find out the volume, we need radius, and we know that radius is half of diameter. Then we have to the we have to take we have to divide the diameter by 2 to find out the radius, and then we will put the radius in the formula p equal to 4 by 3 pi r cube, and the value of pi is 22 by 7 or 3.14. So up to this your first practical is. So any question? এখন হ'ব প্ৰেক্টিকেলৰ কপি এখনে হ'ব অলপমান অকমান স্পেচ ৰেডি থবা যাতে দুটা প্ৰেক্টিকেল কৰিব পাৰা yeah, I can send you the PDF also, but you can take screenshots from uh please take screenshots from this and you have to write down in your practical copy from this slide. Please take screenshot.
কিছুমান দেখা পোৱা নাই লাষ্টৰ 2 লাইন
Last or 2 line কোনটো দেখা পোৱা নাই
last 3 line is not visible
last 3 line is not visible. Okay, wait.
Vernier scale on the scale screw
Is this okay now? এতিয়া দেখিছানে
দেখিছো
okay এইটো হেৰি এইটো স্লাইডৰ পৰা স্ক্ৰিনশ্বট মাৰি লোৱা মাজৰ একেটা প্ৰচিডিউৰ কেইটা মাৰিব নালাগে টেবুলখন মাৰি লোৱা
খন লিখিব লাগিব ন আমি এতিয়া
হা টেবুলখনটো তোমালোকে এতিয়া বনাব নোৱাৰা ন কাৰণটো তোমালোকে প্ৰেক্টিকেলি কৰা নাই তো তোমালোকে থিয়ৰিলৈকে লিখি থবা টেবুলখন জাষ্ট বনাই থলেই হ'ল যেতিয়া ইউনিভাৰ্চিটি খোলে তেতিয়া তোমালোকক কৰিব লাগিব আৰু এইখিনি ঠিক আছে let me show you a video এতিয়া এতিয়া সাউন্ড আহিছে নে ভিডিওটোৰ
নাই
Sound to অহা নাই নেকি?
নাই অহা নাই।
ৰ'বা। Okay, I will send you the video in your WhatsApp group, okay? Okay, students, please give your attendance in the WhatsApp group. The meeting will end soon, and I'll not be able to collect all the attendance. That's why please give your attendance in the physics WhatsApp group, and I will send you the video there. Okay, thank you. You can leave.